Hello, student. Let's go for one more question here. Where a pendulum consisting of massless string of length 20 centimeter and a tiny bob of mass here 100 grams is set up it as a conical pendulum. Its bob now perform 75 rpm, that is rotations per minute. It is not rotation per second, that will be in hertz. It is rotations per minute. Calculate kinetic energy and increasing gravitational potential energy of the bob. So we are viewing pi square, it is actually 3.142 into 2, but we'll be taking pi square as 10. That is given already given in the question here. So let's continue again. So we'll be having further. Let's solve. What are the given data? Let's go for given data here. So given data consists of L equals zero point 0.2 meter, N equals zero point 0.1 kg mass. That will be, I'm converting 100 grams into zero point 0.1 kg there. And here another part is that the n, the frequency, that is given as 75 rpm here. Let's go for 75 rpm. 75 by 60, that will be 5 by 4 rps. Rotation per minute, that is equal to hertz there. Here we will consider now, or here we can say the mass is going not rotating. It is pendulum actually, simple pendulum. So revolutions also we can't say, but we can say that to and fro rotations like that are. G is 10 and pi square is 10 here. G is 10, so pi square will be 10. That is already given. We are assuming G 9.8 converted rounding off. Now time period T will be 1 upon frequency. That will be 4 by 5 seconds. That is 0.5 seconds. Now we have pendulum formula for that. T is equal to 2 pi under root L cos theta upon G. That is formula we are having. So I'm squaring it on both sides. What you'll be getting here? Remember the squaring part, T square is equal to 4 pi square L cos theta upon G here. So adjustment is done now. What is H now? H is L cos theta. Cos theta is H upon L. So H will be your L cos theta. So substitute that value here. L cos theta. Height. This is your height. This will act as a height of this part. Yeah. So if this is your height, then what will be, you will be finding GT square upon 4 pi square. Cross multiply. I'm just cross multiplying this. GT square upon 4 pi square. Substitute the values. 10 into 0.8 square, 4 into 10, that will be 0.16. Now what is cos theta? Cos theta will be H upon L. This is cos theta. H upon L will give you the cos theta there. If you consider that, there is regular cos theta formula, the H upon L. That is nothing but the cos theta. The adjacent upon hypotenuse according to the pendulum here. Uh, so cos theta will be 0.16 upon zero point 0.2, that is 0.8 there. Now next part goes with theta. Theta will be cos inverse of 0.8. You'll be using log table there and getting the answer. So already a minute answer is given. So you'll be getting the answer 36.87 degrees. So converting this 87 degrees into minutes, so that will be 36 degrees, 5 minutes. That is what we'll be getting here. Now next part goes with the V square velocity. V square is equal to RV tan theta formula. So RV is nothing but L, that will be into sine of L sine of 36.87 into G gravitational acceleration multiplied by tan of 36.87. Substitute the value there. 0.2 what we got for L here, that is already given in the question here. And then into 0.6, 10 and 0.75. So finally you'll be getting V square equals 0.9. Now the number you can take the square root of this. 9 square root is 3. So on that basis just I'm continuing. So K, now let's, rather than taking square root and finding V, we can use this idea here. We will be directly taking kinetic energy formula. 1/2 m into V square. So 1/2 into 0.1 into 9. V square is 0.9 here. So just substitute directly the value of 0.9 here. So you'll be getting 0.045 joules there. So increasing gravitational potential and energy will be delta P, that will be mg into bracket L minus h. So what is mg? 0.1 into 10, and what is L? That is 0.2 minus 0.16. That will be 0.04 joules on calculating. Simple calculation I'm not considering. And this is your final answer. So change in gravitational potential energy is 0.04 and kinetic energy is 0.45 joules. Okay, thank you.